Virtualization is the creation of virtual version of something such as server, desktop, storage device, operating system, etc. Explanation. Virtualization is essentially a technology that allows creation of different computing environments. These environments are called virtual because they simulate the interface that is expected by a guest. The most common example of virtualization is hardware virtualization. This technology allows simulating the hardware interface expected by an operating system. Thus, virtualization is a technique which allows us to share a single physical instance of a resource or an application among multiple customers and an organization. Virtualization often creates many virtual resources from one physical resource. Explanation. Virtualization allows us to utilize one single hardware where a single process, or you can say a server rack, is utilized where multiple different technologies and systems work independently and efficiently, and providing more effective utilization of CPU. Virtualization is another core technology for cloud computing. It encompasses a collection of solutions allowing the abstraction of some of the fundamental elements for computing, such as hardware, runtime environments, storage, and networking. Explanation: having isolated and customizable environments with minor impact on performance is what makes virtualization an attractive technology. Hardware virtualization allows the coexistence of different software stacks on top of the same hardware. These stacks are contained inside virtual machine instances, which operate in complete isolation from each other. High-performance servers can host several virtual machine instances, thus creating the opportunity to have a customized software stack on demand. This is the base technology that enables cloud computing solutions to deliver virtual servers on demand, such as Amazon EC2, RightScale, VMware vCloud, and others. Together with hardware virtualization, storage and network virtualization complete the range of technologies for the emulation of IT infrastructure. Virtualization has been around for more than 40 years, but its application has always been limited by technologies that did not allow an efficient use of virtualization solutions. Today these limitations have been substantially overcome, and virtualization has become a fundamental element of cloud computing. So we should move forward now. And let's see types of virtualization. So there are 4 major types of virtualization: application virtualization, network virtualization, storage virtualization, desktop virtualization. All these are major virtualization types. Also other types also considered, such as server virtualization, data virtualization, but these are not in mainstream. We will look at them after we discuss the 4 major types. Let's discuss application level virtualization first. 1. Application virtualization. Application virtualization is a technique that allows applications to run in isolated environments, separate from the underlying operating system and hardware. It involves creating a virtualized package of an application and its dependencies, which can be run on a variety of systems without installation or modification. This approach offers benefits such as simplified deployment, improved security, and better compatibility between applications. Explanation: So application-level virtualization helps a user to have remote access of an application from a server. The server stores all personal information and other characteristics of the application but can still run on a local workstation through the internet. Example of this would be a user who needs to run 2 different versions of the same software. Technologies that use application virtualization are hosted applications and packaged applications. Examples of application virtualization: VMware vSphere, Microsoft Hyper-V, KVM, kernel-based virtual machine, Oracle VM VirtualBox. Now look at what is network virtualization. 2. Network virtualization. Network virtualization is the process of creating a software-based virtual network that can operate independently of the physical network infrastructure. This is achieved by decoupling the network's functionality from its hardware, allowing for more flexible and efficient management of network resources. Network virtualization enables the creation of multiple virtual networks on a single physical network infrastructure, each with its own network policies, security controls, and topology. This can help to improve network scalability, security, and availability. Explanation: So the ability to run multiple virtual networks with each has a separate control and data plan. It coexists together on top of one physical network. It can be managed by individual parties that potentially confidential to each other. A network virtualization provides a facility to create and provision virtual networks, logical switches, routers, firewalls, load balancer, virtual private network, VPN, and workload security within days or even in weeks. Examples of network virtualization: VMware NSX, Cisco ASIC, Microsoft Hyper-V, Juniper Contrail. Now let's see desktop virtualization. 3. Desktop virtualization. Desktop virtualization is a technology that allows a user's desktop environment, including the operating system, applications, and user data, to be hosted on a remote server and accessed from a client device. This enables users to access their desktops from any device with an internet connection, making it easier for IT teams to manage and secure desktop environment. It can be implemented using various methods, such as virtual desktop infrastructure, VDI, session virtualization, or application virtualization. Explanation: Desktop virtualization allows the user's OS to be remotely stored on a server in the data center. It allows the user to access their desktop virtually, from any location by a different machine. Users who want specific operating systems other than Windows Server will need to have a virtual desktop. Main benefits of desktop virtualization are user mobility, portability, and easy management of software installation, updates, and patches. Examples of desktop virtualization: virtual desktop infrastructure, VDI, remote desktop services, RDS, application virtualization, desktop as a service, DAS. Now we should look at storage virtualization. 4. Storage virtualization. Storage virtualization is a technology that abstracts physical storage resources and presents them as logical storage units to users or applications. It allows multiple physical storage devices to be combined into a single virtualized storage pool, which can be easily managed and allocated as needed. This provides greater flexibility and scalability in storage management and enables features such as data tiering, snapshotting, replication, and disaster recovery. Additionally, storage virtualization can help to improve performance by optimizing the placement of data and reducing the impact of I/O bottlenecks. Explanation: So in general, storage virtualization is an array of servers that are managed by a virtual storage system. The servers aren't aware of exactly where their data is stored, and instead function more like worker bees in a hive. It makes managing storage from multiple sources to be managed and utilized as a single repository. Storage virtualization software maintains smooth operations, consistent performance, and a continuous suite of advanced functions despite changes, breakdown, and differences in the underlying equipment. Examples of storage virtualization: IBM SAN Volume Controller, Dell EMC Unity VSA, VMware FSAN, NetApp ONTAP, HP 3PA Store Serve Storage. Now let's discuss other essential types of virtualization. Server and data virtualization. Let's see. 5. Server virtualization. Server virtualization is a technique of partitioning a physical server into multiple virtual servers or machines. This is done by using virtualization software that allows each virtual server to operate independently, as if it were a physical server. Each virtual server has its own operating system, applications, and resources such as CPU, memory, and storage. Server virtualization enables better utilization of physical server resources, improves scalability, and makes it easier to manage and maintain servers. Explanation: This is a kind of virtualization in which masking of server resources takes place. Here, the central server, physical server, is divided into multiple different virtual servers by changing the identity number, processors. So, Each system can operate its own operating systems in isolate manner, where each subserver knows the identity of the central server. It causes an increase in the performance and reduces the operating cost by the deployment of main server resources into a subserver resource. It's beneficial in virtual migration, reduce energy consumption, reduce infrastructural cost, etc. Examples of server virtualization: VMware vSphere, Microsoft Hyper-V, KVM, kernel-based virtual machine, Oracle VM VirtualBox. 6. Data virtualization. Data virtualization is a technique that enables data from different sources, such as databases, file systems, and cloud services, to be accessed and manipulated as if they were in a single place or database. It creates a layer of abstraction that allows data to be accessed, transformed, and delivered without having to move it physically from one location to another. This technique provides a unified view of data that allows users to access and analyze data from multiple sources seamlessly. It can improve data agility, reduce data redundancy, and improve data security by limiting the amount of data movement and reducing the risk of data loss or corruption. Explanation: This is the kind of virtualization in which the data is collected from various sources and managed that at a single place without knowing more about the technical information like how data is collected, stored, formatted, then arranged that data logically so that its virtual view can be accessed by its interested people and stakeholders and users through the various cloud services remotely. Many big giant companies are providing their services like Oracle, IBM, at scale. Data, 8K Broken Bar. Examples of data virtualization: Denodo, IBM InfoSphere Data Virtualization, Cisco Data Virtualization, SAP HANA Virtual Data Model. Now let's see what are the benefits of the virtualization. Benefits of virtualization are: 1. More flexible and efficient allocation of resources. A2. Enhanced development productivity. A3. It lowers the cost of IT infrastructure. A4. Remote access and rapid scalability. A5. High availability and disaster recovery. A6. Pay-per-use of the IT infrastructure on demand. A7. Enables running multiple operating systems.